Dear students, in this video we are going to see the implementation of multi-layer perceptron algorithm using PyTorch framework. I have already posted a video related to the implementation of MLP using scikit-learn library. So MLP is a type of artificial neural network in which we have one or more hidden layers. So basically the neural network having one input layer and one output layer. And in between that we may have one or more hidden layer, then it leads to a MLP algorithm. If we have only one input layer and one output layer, and this will be termed as the single layer perceptron. Multi-layer perceptron is a type of feed-forward and a fully connected network which contain multiple hidden layers in between input and the output layer. As you see in the figure, we have the input neurons where we pass our input features, and we have the output neurons. These output neurons can be either a categorical output for the classification task. If it is a classification task, the output is the categorical variable, that is the class labels. If it is a regression task, we have the numerical output, and that is for your regression task. So every input neurons from the input layer are connected to the hidden layers, and every neurons in the hidden layer are connected to the output neurons. That's why it is called as feed forward and fully connected neural network. And when the MLP with multiple hidden layers increases, and that will lead to a network called as deep learning neural network. The Python framework, and there are basically two Python framework which will be mainly used to create the neural networks, and in that we have the TensorFlow and the PyTorch. These are the two popular deep learning libraries recently used. The TensorFlow library mainly used to create AI models and deploy the AI models for the production in the industry, while the PyTorch framework is mainly used for the academic research purposes. And the PyTorch, the idea behind the PyTorch framework to develop the deep learning model, which is easy to develop, debug and deploy, and also by using the concept called as dynamic computational graph and the Pythonic approach. And what is a Pythonic approach? So Pythonic approach refers to writing a code that follows the Python's best practice. So, and also the PyTorch mainly using a concept of object-oriented programming concept for defining the structure of the neural network. And this is the example for the Pythonic approach. Suppose you want to create list by using a looping concept. So this is a normal way we create a list by using a for loop. First we declare the empty list, then by using a for loop we use the function called as append, and then the list elements are added inside the list. But when we have the Pythonic, so we have a single statement where itself the for loop and along with the creation of the list will be incorporated in a single line. So we have the list comprehension. PyTorch mainly using a concept of dynamic computational graph. So which will allow you to create a model and adjust the models on fly. Whereas the TensorFlow uses the static graph, which is more structured and which is mainly used for the production environment. Both these framework, PyTorch and the TensorFlow, uses the graph representation, and where each node is used to store the input data and also to produce an output, and the edges represent the flow of the data between these nodes. And the graph here used is the directed acyclic graph to represent the machine learning model and the deep learning model. And the tensors are basically the data structure, which is a multi-dimensional array. So that flew through the edges of the graph. That is, the data is passing from one node to another node through these edges in the form of tensors. The TensorFlow uses the static computational graph, so which is a structured environment where we have to define the entire computational model. Then we have to compile and execute the graph in a session. So the graph remains fixed. So if I want to make any changes, again I have to update the changes and I have to explicitly rebuild and compile and execute. Then only the updations will be updated in the graph. And here the main parameters used for it tf.session object and the tf.placeholder. So all communications between the graph with the outside world will be performed by using these two parameters. But dynamic computational graph, that is mainly used in the PyTorch framework, which is not using these type of object and the placeholder. And here the model will be dynamically built during the execution. So even though if you make changes, the changes will be updated for each forward pass. So the operations and the updations will be recorded on the fly and it will be modified at runtime, and it is more easier for debugging when compared to the static computational graph which is available in the TensorFlow environment. And these are some of the basic differences between PyTorch and the TensorFlow. And PyTorch mainly having the dynamic graph and TensorFlow using the static graph. And here it is mainly used for research purpose, and here it is mainly adapted in the industry for the production environment. And it uses the dynamic computational graph. Here it is a static computational graph, and this will be less suitable for production and it will be strongly used for the production environment. Easy debugging, and debugging is more complex, and limited visualization, and here there are various visualization tools with the Tensor board, and growing library support and rich ecosystem. And here it is less optimized for mobile and IoT. Since it is used in the production environment, it is more optimized for the mobile IoT and edge devices. And this is the working principle of the multi-layer perceptron. So we have an input layer and we have an output layer, and these input represents our input features available in our data set, and the output will be classification. So here I am using with the label 0 or 1. So during the forward pass, the inputs will be multiplied with a weight, and these information will be given to the hidden layer. As you know, each node performs two operations. One is the summation and next one is the activation. So the activation function activate, and the output produced from the hidden layer will be given to the input of the next layer. And here also the same operation of summation and the activation will be happen, and based on the activation the output will be triggered and we get the output. And in the output we are doing something called as back propagation. We are calculating the loss function. Loss is nothing but an error which define a difference between actual and the predicted value. So here the loss will be calculated, and based on the loss the weight get updated in the backward direction by using the backward propagation gradient descent algorithm. The backward propagation adjusts all the weights in order to reduce the loss of the model. So now we need to implement this MLP algorithm in the PyTorch environment. So MLP model is considered a deep neural network which having one or more hidden layers, and it uses the back propagation and the gradient descent algorithm in order to update the weights so that it will learn from the inputs in a better way in order to reduce the loss function. The output predictions here using the softmax, because we are going to implement this MLP for the classification. Suppose you are implementing for the regression, the linear activation function will be used as the activation function. And these are the steps to implement the MLP in PyTorch. First, we have to import the required libraries. Second, we have to load and pre-process the data. Pre-processing means we are going to use with the cleaning of the data or standardization of the data or label encoding. So all the pre-processing steps we have to do here. Now we have to define the MLP model. So here in PyTorch environment, the MLP model will be defined with the object-oriented programming concept with the classes and the object concept. And next we have to train the model and then evaluate the performance using the confusion matrix and the other performance metrics such as accuracy and precision, recall and the F1 score. And this is the first statement which is very much important in order to install the Torch framework in the Python environment. So pip install Torch and the related information of the Torch kit first install in our environment of the Python so that we can able to create our MLP model using the PyTorch environment. Next we have to import all the necessary libraries. So here the PyTorch In order to support the PyTorch framework, we have to import the Torch library, which is mainly used to build the neural networks, and scikit-learn to upload our dataset and dividing our dataset into train, test, split, and to perform the pre-processing of standard scalar. And then in the scikit-learn, we have the metrics, which contain all the metrics related to evaluate the model. And then finally matplotlib, which is used to plot the graph by using the pyplot. And next step is loading our data. So here I have loaded a data which is already available in the Python environment. So for that I have already imported the scikit-learn with the dataset, and from that dataset I am loading the iris dataset. So this iris dataset having 4 features which represent the features of a flower, and based on that it will be divided into 3 classes. So my input layer having 4 inputs to the input layer neuron, and I have the 3 classes from the output layer either with a class of 0, 1 or 2, which represent the corresponding class label of the output. And now this iris data, we have both the features and the target. So the X represent the features and the Y represent the target. So this contain all the features and the Y represent the target label. And next step is if you want to clean your data, so you can clean the data if there is any outlier and noise. And now I have a clean data, so I am not doing any pre-processing steps separately for cleaning. And now I am going to standardize the data using the standard scalar. And this standard scalar is again available in the sklearn pre-processing library, and that you have to import and standardize the data. Next is we have to split our input data into 80% for training and 20% for testing using the method called as train, test, split. We pass our input, also our output label, and the test size is 0.2. Suppose you have 100 data totally, that is 100 instance totally. So from that 80 will be going for test training purpose and 20 will be going for testing purpose. And this random state help you to randomly pick our data to create the testing and training. So every time it will remain with the same set of training set and the testing set. And the next is an important step which will convert our data into a PyTorch environment, because in the PyTorch framework all your data will be considered as a tensor. So tensor is a type of data which only flow a data in your graph model. So we need to convert our normal data or a data frame or NumPy into a tensor model. So for that conversion we have the torch.tensor. So this torch.tensor convert our training data and the testing data to the type of tensor data. So tensor data is nothing but it is a multi-dimensional array format. Similarly, the Y-train and Y-test also converted to a tensor format, because that is a corresponding data structure format which will be used in the PyTorch framework. After doing that, we are going to define our MLP model definition. As I already told, the model definition using a concept of OOPS concept, because PyTorch we have to define our models using the classes concept, classes and the methods concept. So here the first one is the constructor. So we have defined a class called as MLP, and which is using or which is inheriting from the base class called as nn.module, which is used to create a neural network models. And here we have a constructor, the constructor having the input size, that is the number of features, and how many hidden layers we have, each hidden layer how many neurons you need to have, that will be given in the hidden size, and the output size, that is how much target you have for our output. And here we are going to define a linear layers, because we have the input layer and then we have the first hidden layer. So here it represents the first hidden layer takes the input. Here the example it is 4, and it is producing an output with the hidden size whatever we have given. For example, I am going to give 32, and then this will be passing to the next hidden layer, and this 32 will be given as an input to here, and we are having the output is 16, and the next hidden layer, that is H3, there 16 will be the input and 8 will be the output, And finally, we have the output layer. The output layer producing a 3-class label. So here all the layers are arranged in linear model or in a sequential way. So we are creating a neural network with the linear models to create a sequential structure. So we have the 4 linear layers, and the activation function we are using is the ReLU. And next is the forward. So here in forward, it will do the forward pass operation of our neural network model. So every input layers or the hidden layers that having the ReLU as a activation function in order to do the operations of summation and the activation and produce the output. The last layer is a output layer, so it doesn't need any activation function. It will just use the softmax to create the output as either 0, 1 or 2. And to check with the loss, we are using the cross entropy loss. It is mainly used for the classification purpose. And now we have to initiate our model, that is we have to train our model. So we need 3 inputs for our constructor, that is the input size, that is the number of features, and then the hidden size, each hidden layer, what will be the size of the neurons to be kept, that will be decided in the hidden size, and the output size is the number of class labels. So depends on your problem, read your data, identify how many input features are available in your data set and what is your target and how many categorical variables are available in your target. So based on that, you define your input size and the output size. The hidden size, you can keep 1 hidden layer or you can keep 1 or more hidden layer. So that depends on your problem domain. You can increase the hidden layer size. And now we have initialized the MLP by calling the constructor. We are passing the input size, hidden size and the output size. Now the model get just initiated, or the object of the model get created. So PyTorch mainly using the object-oriented programming concepts. So all your neural network layers are defined inside the class, and we are initializing that class function or your neural network model by creating an object by passing the information to the constructor. And next is we have to define the loss function and the optimizer for the classification. So as I told, since we are using the classification concept, so the corresponding loss function to evaluate our prediction and the actual is the cross entropy loss. And to optimize our model, we are using the ADAM optimizer. And the learning rate used here is 0.01. And for every iteration, I need to know whether there is an improvement in the loss value. So to store that, we have created an array where you can store the loss values of every iteration. And now we are going to repeat the process for the 100 iterations. So we have given initialized the number of epochs and how many times our model has to be trained. So we use a for loop, and now our training data, because we created a model already, we initiated the model already. So we are passing our training data to the model. So we know that the model having input layer, then 3 hidden layers and the output layers. So it using this forward function, and by using a ReLU, this will be learning and producing the output. So that only we are getting as an output. Okay. And now we are calculating the difference between the actual output and the predicted output in order to compute the loss. So the loss get computed. And now these are all done in the forward direction. Now we have to update the weight. So to update the weight, we need to move in a backward direction. So when we move the backward direction, the weight updation will be done using the algorithm called as back propagation gradient descent algorithm. So for that, initially we initialize the 0 gradient, and then because it needs to be initialized for every iteration, that's why we are resetting the gradient for every iteration. And now we are initializing our backward, that is the loss value whatever we got, that get based on that your backward propagation will be done, and all your weights get updated based on this loss function using the concept of back propagation gradient descent algorithm. The weight gets updated using the back propagation gradient descent algorithm. So whatever loss values you get at the end of the iteration, that will be stored in the loss array. Okay, so because at the end we need to plot it, and now for every iteration we need to know that what is the loss value we got, because since we have now 100 iterations, so for 100 iteration what is the loss value we are trying to implement or we are trying to display. So I don't need to print all the 100 iteration loss. So to have it for every 10 iteration, I am trying to print what is the loss value, whether it gets improved or decreased. We are going to see with that. And now we have to set the model for evaluation. So far our training is over. Now we are passing, or we are going to evaluate the model by passing the test data. So our model is ready for the evaluation. We are passing the test data to the model. So again it is producing the output. Based on that, the maximum value, you are getting the predicted labels, and that predicted labels will be available in the variable called as predicted. So again we need to calculate what is the difference between our actual and the predicted for the testing values. So we need to perform all the values in the NumPy arrays. So all your tensors are now converted again into a NumPy format. So we converted our y test is our actual label, and then this predicted NP is our predicted label which we got for the test data. So now we already have the performance matrix which is available in the scikit-learn, and we have already imported that performance matrix. So we have to use that for the confusion matrix, accuracy score, precision score, recall score and the F1 score. Once all is calculated, we just print all those values. And this will help you to plot the loss curve. Already we calculated for every 10 iteration what is the loss value. We have stored in a particular array called as loss value. So for every 10 iteration, we are trying to plot it. So this will tell you basically initially your loss will be very high. So when the number of iteration increases, automatically the loss gets reduced. So this will represent your number of iteration and this will represent your loss. So this is a loss curve. This will help you how your model try to improve the model accuracy by reducing the loss. So I will just show you a demo, so that will help you to understand how this is working in your Python environment. So first we have imported all the corresponding libraries, and then we are going to load our data set. So now the data has loaded. You want to know how many data are available. So I am going to just show the input data, totally 150 instances, and in that 4 features are available. Okay, and now the training, so it is again 0.2. So out of 150, 20% will be going for testing, remaining 120 will be going for training purpose. So 30 will be going for testing, 120 will be coming for training purpose. And then we have defined the MLP model, which define the constructor and followed by the forward pass of your MLP model operation. So if you want to reduce or increase the hidden layers, you can adjust these linear representation of layers here. The activation function used is rel. And we have to initiate the model. So we define what is our input feature size, what is our output class labels, how many class labels, and how many hidden layers you need. Now it is having 3 hidden layers. And we have initialized all our loss function and optimizer, and we have run this training loop. So for every 10 iteration the loss. So if you see here, initially the loss will be, after 10th iteration the loss will be 0.87. But when it coming to the 90th iteration, it will be around 0.0410. So further it is reduced to 0.0404 at the end of the 100th iteration. And we are evaluating the model. So we are trying to predict the output of the model for the testing data. So to evaluate the final result of the actual and the predicted of the testing data, we need to convert again back our tensor data to the NumPy arrays. So this is your conversion. Then you have to evaluate the performance metrics. So when we run it, we get the confusion matrix, accuracy, precision, recall, all those information. And finally, we have to plot the loss function for every iteration, that is for every 10 iteration. So you see here, this is our loss curve. So initial iteration, the loss will be high, but later when the number of iterations increases, the loss is getting reduced. After some time, it will be maintained with only a small or little variations between the loss values. I hope you understand how to implement the MLP in the PyTorch framework, and also what is the working principle of the MLP to define an artificial neural network with one or more hidden layers. Thank you.